Hello and welcome back to my channel. Today we are with the last episode of the ongoing series Visibility of Divisibility Part 4. In the last part, Part 3, we have addressed some questions like the generalized strategy 2, how does it work, justification, and applied for any P in general, and does it lead to the popular test for P equal to 7? And some unanswered questions were there after part 3, the questions addressed here in part 4. Like, can we extend strategy 2 to get another general strategy called strategy 3? And how does it work? And is it applicable for any P in general? So let us start with a awkward question that if AS is this 19152, this 5-digit number, is it divisible by 7? So already we have had two strategies, 1 and 2, and we'll apply both for this number for P equal to 7. First strategy 1 that we have discussed in part 2 actually, AS is such a number of digits A0 to AN, and then what we have done, we have extracted a smaller number C from S using these digits as MI, AI. MI are the multipliers, and we have evaluated those multipliers for I equal to 0 to 4, like 1, 3, 2, 6, 4. So you have to get now C. So in red color 1, 3, 2, 6, 4, and multiplied by AI. So it goes from right to left because A0, A1, A2, A3, and A4. So 2, 5, 1, 9, 1, 2, 5, 1, 9. So you get 77, and 77 is divisible of course by 7. So you can declare that the given number, this 5-digit number, is also divisible by 7, and that is how we applied strategy 1. And strategy 2 is a bit different. What we do here to get this truncated this C, we truncate by dropping the last digit A0 and multiply by R, and then we subtract from the truncated number N. So R, what is the R value? And that also prescribed that it is Pk minus 1 by 10. So we have to search for a suitable K so that R becomes an N. That's all. And that we have discussed in the last video part. And for example, for this example 19152, we have taken the number for K equal to 3. We can put it here 3 and P equal to 7. So 7 into 3 minus 1 by 10, that is you will get R equal to 2. So this truncated number after dropping the last digit, it is 1915, and you have to subtract 2 times A0, that is 2 into 2, 2 into 2. So you will get 1911. But still it is a 4-digit number, big enough. So you may not be comfortable to find that whether this C is divisible by 7 or not. So in that case, what you can do, as I have already prescribed in the last video, that you can treat this C as a fresh S and apply the same strategy again. So now this time your S is this 4-digit number. Now you are dropping the last digit 1, A0. So the remaining truncated number is 191. So the final C is 191 minus 2 because R is 2. So 2 into last digit 1, so 2, 189. So now you can maybe say that okay, 189 is divisible by 7. I can see, right? Now let us do something different. The same example. Here you see I have colored last 2 digits as red, 5 and here it was only one color, 2 and 1, these 2 steps. But here we are 5, 2. That means we are going to drop both these digits 5 and 4. Okay, and we have introduced R, but here K is 3. So the formula is that 191 minus 2 into 5, this 2 is coming from R, and 3 into 2, this 2. So this 5 is coming from A1, the digit A1, and this 2 is coming from A0, and we are multiplying by 2 and 3. Why? We don't know. So the question is that what is going on here? What we are doing? Well, so we are actually doing, you can generalize that you are getting a C by doing this. You are truncating the number S, given S, by dropping 2 digits A0 and A1, and you multiply A1 by R and A0 by T and subtract it from the truncated number S. And for this particular example, we have deliberately used R equal to 2 and T equal to 3, as we have seen in the last slide. You can go back if you want. So, now clearly example, so we have got R and T in green color. Initially it was only K, but this time I have introduced another L, and which are 3 and 40. Okay, and we have dropped 2 letters, 2 digits to get 191, and then we have subtracted 2, R is 2, so R A1, A1 is 5, so 2 into 5, minus T A0, so T is 3, T is 3, so 3 into 2, because A1, A0 is 2. So this time you are getting in a single step 175, and probably you are happy that okay, 175 I can imagine, visualize that it is divisible by 7. But the question that R equals to 2 and T equals to 3 in this general formula we have used, where do they come from? And my prescription is that, like the previous one, that R is Pk minus 1 by 10 and T is Pl minus 1 by 100, where this K and L are integers, plus minus integers or 0. Okay. So, for example, P equals to 7 and K we have used 3 deliberately to get an integer R that we have already got, and that is 2. And in case of T, we have used L equal to, by quite searching, that L equal to 43 and no less than 43 will get. So 7 into 43 minus 1, and that would give you the first integer T. Okay, you can have more than say 43, some value for L that you may get, but not less than, and you get the minimum T value is 3. So we have got the evaluation that y R equal to 2 and T equal to 3 used by applying this to formula. Okay, but the question remains that where from this formula comes, that R is Pk minus 1 by 10 and T is Pl minus 1 by 100, where K and L are 0 or plus. So these questions remain, and these are the most important questions, and the answers I would give in a while. But before that, let us see for other terms. So the formula written here, R is this and K is this. So if you apply for different p value, in general any p value actually, that p equal to 3, 7, 11, 13 and 17 I have done, and I have chosen deliberately some numbers which are divisible by the corresponding p values, and we have seen that by applying this formula in R A1, this should be R and this should be T actually, sorry, R A1 minus T A0, where everything is listed, that how you got the R values for different p, for which choice of K and L, to ensure that R you get is an integer, and finally you have got this last column number which are clearly divisible by the corresponding p value, right? So that justifies that why the how the formula works. It narrates only, not justifies. Justification that you will get in a while. Now justification. So the question, it is very similar. In the last episode we have seen for the strategy 2, and it is very similar, that you have truncated to get this one n by dropping 2 digits A0 and A1. So you can write n A1 unit place, 10th place and 100th place. That gives you in decimal system the value of s. So you can write what is the relation between s, n, A0 and A1. Clearly S is now 100 plus n, so 100 into n plus 10a1 plus a0 plus a. So for example, a is equal to 6, 7, 8, 9, a 4-digit number. So n is 67 because we are dropping 2 digits, 8 and 9. A1 is 8 and A0 is 9. Then 6, 7, 8, 9 is 100 into n plus 10 into A1 plus A0, 9. Right? So it's okay. Now I can write that S. So you bring from right to left this 10 A1 and A0. So you get S minus 10 A1 minus A0 is 100 n. Right? Okay. Now a trick like the earlier. You subtract 100 R A1 and 100 P A0 from both sides. Okay. So let us see what happens. So S minus 10 A1 minus A0 minus 100 RA1 minus 100 TA0. And on your right, 100 N was there, minus 100 RA1 and minus 100 TA0. So you can take common 100 from here. So you get N minus RA1 minus TA0. This. So you can manipulate a little bit more. Here you can take common 10A1 from this value and that value. So you get 1 plus 10R from here, 10R. And you can take common A0 from these two terms, you get 1 plus 100T. And on your right, this 100 N minus RA1 minus S. Okay. So now you bring all the terms except S from left to right to get this 10A1 1 plus 10R minus plus A0 into 1 plus 100T plus the right one 100 N minus RA1 minus A0. So I have repeated it again, the last expression, and now we can say that S is to be divisible by P. The right hand side has to be divisible by P. Okay. Now it requires that all the terms, that means 1 plus 10R, this one, 1 plus 100T, this one, and N minus RA1 minus T. All these three have to be divisible by. Okay, fine. That means you have to find suitable integers R here and P here, so that these two are divisible by P. And the last term, and that is the checkpoint that we have prescribed for our strategy. Okay. So in other words, if C you define in this way and is divisible by P, then S is divisible by P, provided the two terms 1 plus 10R and 1 plus 100T are divisible by. Right? Got it? So if 1 plus 10R has to be divisible by P, that means it has to be integral multiple of, that means Kp, where K is either 0 or plus or 0. So a little bit of manipulation would give you R, Kp minus 1 by K. As usual, is the last case we have seen. But the new one is this one. So the 1 plus 100T is also divisible. That means it also has to be integral multiple of P. And here L is that integer, and manipulation would give you that LP minus 1 by 100. Sorry, this should be LP, not K. This should be F. Sorry. And that are exactly the R and T we have used in our description. Right? So we have got the justification why strategy 3. So taking together part 1, 2, 3, 4, let us quickly see what we have done. We have seen the class 4 level divisibility test by prime 2, 3, 5 and 11 and in non-prime 9 by using the test 1, 2, 3, and then we have prescribed a general strategy which leads to all these 3 tests by taking C like this, mi of the multipliers, and that were given as 10 minus b to the power I by t, and its remainder. And we have presented also a general strategy 2, where we have taken an R and by some prescription pk minus 1 by k. Okay. And divisibility test for 1, 2, 3, 4 part, these 4 parts, we also have discussed general strategy 3, and that is dropping two numbers, and the general formula for C is n minus R A1 minus T A0, where R and T are given by these two expressions, provided K and L are integers, plus minus or 0. Not only that, we have seen that all the strategies are applicable for any P, and particularly for P equal to 7. Yes, we have got the popular one from strategy 2, not from strategy 1, though it has given a new solution or another solution for P equal to 7. And in our 4 videos taken together, we can say that we have explained why 1, 2, 3 strategy 1. Okay. So thank you very much for bearing with me for all these 4 videos. Thank you once again.